Okay, welcome to APNIC eLearning web class. Today is January 24th, 2018, and it is 5:03 p.m. in Brisbane. And in this session, we are going to talk about the BGP basics, some basic operations and the principles in BGP, this routing protocol. Before we start, I would like to introduce myself. My name is Jessica. I am a training officer in APNIC, and I am doing the routing and IPv6 and network security and IIM training in APNIC. And in this session, if you have any questions, please type in the chat. I will try to answer the questions as soon as possible. And so you cannot use the microphone that function in this Adobe Connect. After this session, I would share the survey link and the handouts with you, and then you can download the handouts and for your self-study. Okay, so now we will start this session. And in this part, you can see we are going to talk about first what is BGP routing protocol, and then the BGP features. So what are the features for this protocol? And the first feature is the path vector. And then what is the path vector routing protocol, and about the path and the vector information. And for BGP, we need to talk about the peering and transit, because BGP, this protocol is used to connect different networks. And between different networks, the relationships, some are peering, some are transit. These are very important for different networks. And then we move on to principles, the general operation, and some terminologies used in BGP. And for BGP attributes, we would just mention this one and some functions for the BGP. And for the last part, we will show you some command line, the configuration example on Cisco IOS for BGP configuration. So that will be for 1 hour we will talk about. Okay, so we will start. For the first one, what is BGP? We know BGP is a routing protocol, border gateway protocol. This routing protocol is also in the eBGP, is used between different networks to connect different networks, and used to exchange the routing information. So this one is very important. The BGP, this protocol is mainly used to exchange the routing information. And so he would carry the routing information from one network to the other network, and then you will know what are the IP addresses, what are the networks in the other networks. So BGP is very important for the internet. And for the learning, you can see we have the different RFC, 4276, 4277, basically is described in the 4271. So you can go through this RFC, because the vendors, when they are developing the devices, the routers, switches, who can support the BGP function, they would follow the RFC. Most of us, they would follow the RFC. So you can see the basic functions, learn the detail of this protocol, you can learn from this RFC. And then continue for BGP features. First one, it is a path vector protocol. And when he send the routes to the others, we can call the routes are the paths. The routes are carried the routing information. And in this routing information, we will carry the path. The path will be carried inside, and also the vector. So later the next page we will talk about what is a path, what is vector. So in the AS path, that attribute, we can carry the path and vector, both information. So we call this is a path vector protocol. Will be talked in next page. And then next feature, incremental updates. You can imagine, because BGP is used between different networks for the internet, and for the whole internet, there are so many routing BGP routes And you can see currently the BGP routing entry is about 600,000 prefixes over this number, and these are the prefixes IPv4 BGP routes. And so if every time one border router sends you 600,000 prefixes to your border router, every time send all the routing information to your router, and then you can see it will occupy also the bandwidth and also take the CPU, occupy the CPU or the hardware to work about this. And so for BGP to avoid this consumption, and then they designed to update the only incremental information. So that's why we have the incremental updates. So between two neighbors, and if they're between two border routers, only if there's something changed. The first time, of course, they need to send the full routing table, full BGP routing table to the neighbor. And after that, and then they would only send the updates. Anything changed, and then he will send the information. And then next is for the many options for policy enforcement, policy part, and for the internet backbone. You see, for the policy part, this is important because between different networks, what prefix I want to advertise to my neighbor, what prefix I want to get from my neighbor, and from which border router. Maybe you have two border routers and you want to implement a different preference, and which one you will get which one, then you will deploy the policy. And for BGP, it is easy for us to implement, and there are so many different experiences to implement the policy paths, the many options, and that is the attributes. So BGP, the BGP attributes. BGP, oh, so here should be BGP attributes. BGP attributes can help us to finish this policy enforcement, and also we can use, based on the default prefix you want to announce some paths, the prefix, detailed prefix, or the aggregated prefix to make a decision. So these are the many options for the policy enforcement, and because BGP can implement multiple policies, so it is very flexible to control the traffic and control the routing paths. So also widely used for the internet backbone. And for the internet backbone, there are so many routes, and he can carry all these routes, and also can deploy different policies to filter these routes. And for the CIDR, we know nowadays OSPF, ISS, and BGP, these we are using the common protocols. All of them are classless interdomain routing and without class. And last one is the autonomous system. So BGP is used to connect different networks, and the different networks, we also have another name to describe. You can talk about it as the autonomous system. Autonomous system, this is a group of routers, and this group of routers, they are under the same policy and the same administration policy, management, the same policy. For example, in one ISP, maybe the whole network is one AS, and then they are using the same policy to talk with the other networks. So this is one autonomous system. This group of routers are in one AS, we call like this. And for the other company, maybe they have multiple for different parts of the different based on different location, and maybe a north part, south part, and east part, west part, because maybe the country is very big, and then different parts, they are using different policies, routing policies, and so maybe there are 4 autonomous systems in this network. So in one ISP, they have divided their whole network into 4 parts, and each part will have their own autonomous system numbers, and then they are having different policies between each other. and they will use their own AS number to talk with the other paths. So the autonomous system mainly based on whether they are running under the same administrative policy path. And so this is not depends on whether they are belonging to the same company or not. It's based on the policy and how you design the network. So BGP will be used between different autonomous systems. We also call this is AS. So here, AS, between different AS, and or maybe inside one AS, how we are running BGP. And then what, as I said, we are going to talk about the path vector routing protocol. What is the path vector routing protocol? Path vector routing protocol is used to send the routes between different autonomous systems. He will send the routes. He will define the route with using some information, and that information is the AS path. Okay, I will circle it here. AS path, and the AS path will carry the AS information, the connection of AS numbers, and that passed from one, for example, from network A, network B, network C, and then there is one route from network A and send it to network B and send to network C, and the AS path will carry all the AS numbers on along this path. Is the network A has AS number, network B AS number, networks will be seen on network C when they receive this route. We will have an example. So initially, the AS path is used to avoid the routing loop. Because for the routing path, when we learn the routing information, we don't want to have the loop. So avoid the routing loop is very important. And so we will use this topology as an example to say what is AS path and how can we call this is path vector, and then how to avoid the loops. So here we just suppose if here there is one route 1110/24 originated from AS6461. So here in AS6461, he said, oh, I will net advertise one route into BGP. And AS6461, you can see these clouds, one cloud represents one group of routers. So the AS number is the autonomous system number 6461. His autonomous system number is 7018. His autonomous number is 6337. Okay, so when this AS6461, he advertised his route to AS7018. When he advertised this route, and this route will carry the AS path information. So what would the information look like? And that will be 1.1.1.0/24. And the AS path will be 6461. So this in the bracket, the 6461 is the AS path. And so this route will be advertised, will be received by the AS701018. This border router, he will learn this route. And when this route, if this route is advertised inside the AS path is still 6461. But if this route is advertised from 7018, the border router, to the other border router, to the AS6337, and then what route will he receive? Because we said the AS path will record all the AS numbers information.